are live, the Infinite Academics Live. My name is Jonathan Milman. If you do not know who I am the CEO and founder of Infinite Academics, where we focus on getting kids into the best possible colleges. A couple cool things that happened this weekend. This last Saturday, we did a college info session that had a little over 150 people show up, which was pretty cool. Pretty cool. Every seat in the house was basically taken, and our Zoom broke, and all our systems broke. And anyway, okay. If anybody wants to see that session, we are available on YouTube, Facebook, TikTok, basically everything. We posted a whole bunch of different things. So we posted basically everywhere. And by all means, okay, you can get access to that. I was going through three particular case studies when it came to when it came to students who got into Ivies. Went through how to break down the college essay, the entire college process from start to finish. We broke down a ton of really, really cool stuff. So if you want to check it out, okay, it's on our YouTube channel. Just follow and subscribe so you guys can get a good understanding of exactly what's going on and get a good grasp of like exactly how the college process works. Now, another announcement. Okay, for those of you who do not know me, I put my money where my mouth is, which basically means that I am registered to take the SAT this upcoming Saturday. Okay. Myself and my entire crew. So Wyatt, Arcelina, okay, both of them, which are my main primary SAT tutors, soon to be Tommy and Isis as well. We are all taking the SAT this upcoming Saturday, okay? We're taking it in Medgar Evers something. I don't know. It's something in Flatbush. Should be Flatbush, downtown Brooklyn, something like that. Okay. According to my kids in my class, it's 40 minutes away. So it should be very interesting to see. Yeah, okay, I'm going to be posting the entire progress from start to finish. I'm going to be posting exactly what I'm doing to prepare for the exam. And yeah, I am preparing for the exam. I'm kind of making the announcement to like 1,100 kids. So, kind of important for me to, explain that this is not a joke. This is real. We take the exam. Let's push this and let's see how far we can get with this. Okay. So I'm going to be posting the entire journey from start to finish on a daily basis. I'm going to be sending out text messages and email blasts everywhere, talking about exactly what it takes in order to get into the best colleges in the world. And we're going to be really doing this and breaking this down every single step of the way. Okay. But today, for our regularly scheduled programming, we are going through College Board Test 11. Some of my students have been telling me, this is the hardest exam ever, John. This is so different from your practice exams. And a lot of my other students are going, this is the easiest thing ever. Can we go back to your exams? Yeah. I have a lot more students telling me that this is a joke rather than this is really, really hard. I had one of my students score 1560. I don't know if she's going to be really happy with me posting this. Screw it. Okay, I'm going to do it anyway. If she gets upset, I'll pull it down. Here you go. Miss Ellie Steppenkoff. Okay, I guess it can't really be a complaint. You can't complain. Like, everybody's been telling me, like, it's so freaking hard, right? And then she literally, like, guys, you can see my text message with her. She literally took this on Saturday. Okay. I mean, this test is too easy. Like, I don't know why people are like freaking out about this. This is not different. It's the same exact problems, the same exact math problems, same exact concepts. And in my opinion, this is way easier than than a lot of the practice exams that you guys take. Like, so what are we talking about here? Okay, this is not complicated. Just stop overthinking and stop overanalyzing this. Okay, really just understand that these are the same exact problems every single time. You're just freaking out. You're just panicking, and honestly, you're freaking out and panicking for no reason. So keep it simple. Don't go nuts with this. Anyway, I'm gonna stop complaining, and we're gonna get into our regular scheduled programming. So for today, I have a lot of students who are most likely gonna be super scoring math, but I'm gonna do like 45 minutes math. I'm gonna do like the last. Uh, I'm gonna do module two as much as I possibly can. I really want to get through module two math. Okay. After we get through module two math, then I'll go through the rest. Okay. I'll go through as much as I possibly can. But basically, I want to go through the hardest problems on module two math. I'm going to be ripping through those since they're supposed to be the most difficult. Okay, so we're gonna really get into those as much as we possibly can, and then we're gonna see exactly where this goes. Okay, so that being said, I'm gonna open up Desmos real quick, and we're gonna get started. Okay. I'll open Desmos on my computer. Like if I have to use Desmos for and show you guys something, I'll show you guys obviously. But right now I want to make sure that I have my handy calculator with me. Yes, you can use a calculator. Okay, I even have a whole video on how you can program a dictionary in here, but that's besides the point. Okay, hope nobody's watching this that can really react to that. Regardless of the situation, it's their problem in my opinion. So this is for educational content only. Hope I don't get sued. That being said, let's start from the beginning. Let's start from the end. I don't want to start from the beginning because the first couple problems on math, even module 2, is going to be a joke. Okay, it really is. By the way, this is the paper format. Okay, the real SAT, the digital one, is going to be 22 questions. Okay, so it's not 27 questions. Just in this case, the paper format has more questions because they're going to pull from this database, and we're going to create different versions of the exam based on the adaptive capability of it, regardless of the situation. Let's start with question 27. Okay, supposed to be the most difficult problem ever. Spooky. Whatever. All right. An area of 46 square nautical miles is equivalent to K kilometers. Okay. 46 miles squared. It doesn't matter whether it's nautical miles or just miles. Okay. Keep it simple. And this is equivalent to K square kilometers. Okay. So basically, I'm trying to convert this. This is just unit conversion. I'm going from 40. What did I write? 4K? Why did I write 4K? Oh, because it was supposed to be 46. Whoops. Well, hold on. Why is this a hole? Okay, so it's 46. I'm writing K. 46. I don't know why I'm writing K at all. I'm being weird. Whatever. 46 miles squared. Keep it simple. And this has to be converted to square kilometers. Okay? Not difficult. Like this is dimensional analysis at its finest. All right, what you do with dimensional analysis is always the same. You create this little like table thing. Okay, always. You put the thing that you're given on top. Always your givens go on top. And what you need to do is you need to get rid of the units that are on the bottom. So it's 46 miles squared, and you want to convert it to nautical kilometers squared. How do you do that? Real simple. I'm literally just going to convert this and say, okay, 1 nautical mile. I'm going to put have the miles on the top, miles squared, I should say. I'm going to put 1 mile is equivalent to 1.852 kilometers, right? So you'll notice that I have miles. I'm going to put a little laser pointer. Miles squared and miles, but they won't fully cancel out because I have miles squared and miles. I need to get miles squared and miles squared. The way I do that is I square this whole thing. So that will get me 1.852 squared over 1. So look what happens now. I get 46 miles squared over 1.85, well, squared. I'm going to do that on my calculator. So I get 1.85852 squared, 3.4 29904. That's kilometers squared over 1 mile squared, right? Because I square everything in here. I square the units, I square the values, I square everything. So from here, it's kind of a joke. So I just do times 46, and I get 157.77. And what do I need? It's the nearest tenth. Okay, cool. I just want to double check. Okay. It's the nearest tenth, so it's 157.8. That's my final answer. Done. And how many spaces do you have, and how many like, values can you put in here? It's 5. 5 is the maximum number of digits, and the decimals included. So I go 1, 2, 3, 4, 5. So when you put this in, you put in the whole thing. That's why it has to be to the nearest tenth. Pretty straightforward. Dimensional analysis. If you do not know this, you're basically screwed on Saturday. Just a heads up. Next, in triangle XYZ, the measure of angle X is 90 degrees. Okay, so I know it's a right triangle. I'm going to call this X 90. Point W lies on line segment WYZ. So Y, Z. Let me get rid of this because it's from the previous problem. Cool. Now W lies on line segment. Okay, I'm going to make this right here. W. And segment WX is perpendicular to line segment YZ. So I'll cut that in half. Awesome. The length of segment WY is 572. 572. Okay, when we have something, it's perpendicular. It's a segment YZ, so I see. So basically, I'm gonna get a right angle right here. So I have like, I'm chopping this in half in two right angles. The only way that's possible is if it's an altitude, it has to cut it in half. But that's besides the point. Like so now I'm pretty sure the value here is 572 as well, but I'm not gonna make that assumption. Let's just say we know nothing. Okay, there's like multiple ways to do this. Like just like there's multiple ways to solve any problem on the SAT. The length of segment WX is 429. WX is 429. Okay, cool. And then it says, what is the value of tangent of z? Okay, so I don't know what the actual value of z is, but like I can kind of easily find this, right? So 429 tangent z, cool. So what I'm gonna do here right now, I can do a couple different things. What do I really want to do? Did I make I think I made a mistake. It's not WY, I think it's, which one's WY is 572. Cool. WX is 429. Cool. Okay, I got that. Okay, so what I can do here is the first thing I'm going to do is I'm going to find XY, because I could just do Pythagorean theorem here, right? If you guys see this, leg squared plus leg squared equals hypotenuse squared. So I'll go, I'm going to try to find XY here. And xy is equivalent to 429 squared plus 572 squared. And this obviously has to equal x squared. Okay, so if I do that, 429 squared plus, I don't know if this is the fastest way necessarily, but definitely accurate. So I get 511,225, and then I'm going to square root that. So I get 715. Okay, so xy, the line, is equal to 715. Cool. Now, what do I have? I have that value is 715, so I have the opposite side to tan, z. Now I just need to find the adjacent side. Okay, what can I do here? I can find a couple different things. I could say that they're equal. I don't want to say that they're equal. I could do, what's the easiest way to do this? I can do by proportions. That's also a possibility. I can also do AB equals height squared. I could do that as well. There's like 1,000 different things I could do here. Okay, I'm just gonna do the AB equals the height squared. So like, here's a key rule, okay? And this is super rare, but it has been coming up a decent amount of times. So if you ever have like a right triangle like this, and if I have any right triangle, any kind of altitude, and I cut it in half, I can say A times B is equal to the height squared. Okay, that's basically the rule here. Whoops. And that's essentially nothing more than it's like a proportion. Okay, it's a proportion rule. I'm gonna do it this way because, in my opinion, that's easier. I'm gonna try to find an easier way to do this, but regardless of the situation, right now I have 572. That's my A, and I'll call that B equals the height squared, which is 429 squared. So I'll do 429 squared divided by 572, and I get 321.75. So it turns out that they're not actually equal. Regardless of the situation, I know that value, which means I know the hypotenuse, which means I can easily find the adjacent side. Is there an easier way to do this? I don't really see the easier way to do this. The only easy other way to do this is really like figure out the proportions here, which I don't know if that's really easy. So let's just say, hypothetically, I'm going to put this in blue. So I'm going to make this angle 40 and this angle 50, right? So if I, let's just say, hypothetically, um, if I go and I want to find out this angle is 40 degrees. So let's just say I have the 429, the 40 degrees. So the opposite of the 40 degrees is 429. And the adjacent to the 40 degrees is 572. And then I want to do the same thing here. The opposite to the 40 degrees is called an x. And the adjacent is 715. So that should give me the same exact value. So 429 times 715, divide that by 572. I get 536.25. 536. So that's what I get for the x value. Let's see if it's the same thing here. So the entire hypotenuse here is 320, so 321.75 plus 572. So the entire value is going to be 893. I'm doing this in multiple ways. Okay, I already have the answer. That's pretty straightforward, but I want to do this in multiple ways just to prove it out for myself. Okay, because this is exactly what I would do, especially for a question 26 on mod 2. And no, I don't think this is difficult. I'm making it difficult because I'm trying to really break down each and every single aspect here. So if I have 893.75, right, I'm going to have 715 squared plus x squared equals 893.75 squared. So I'll square this and subtract it from 715 squared. Square root that. I get exactly the same thing, 536.25. Okay, so I get the same value here and here, either if I do it as a proportion or I decide to do the AB equals height squared. Either one doesn't matter. Now, if I think about tangent Z, it's always opposite over adjacent, which I'm going to put that in red. Opposite, whoops, opposite, adjacent. Okay, so I'm literally going to do 715 divided by 536.25. I get 1.333, or I change it to a fraction, 4 over 3. Boom, done. Okay, nothing complicated, literally proved in multiple ways because I'm super paranoid, and that's exactly how I'm preparing for the SAT myself. I'm making sure I go through every single problem multiple ways to make sure I do not make a single mistake, no matter what the situation is. Accuracy is king here. Accuracy is king here. I cannot emphasize that enough, okay? And for all those of you who are my students and watching this live, guys, I know I've never gone through this. I'll go through it tomorrow, okay, since I'm kind of seeing it and it could kind of be useful. I don't know, okay? Regardless, you can do proportions here, so it really shouldn't be that much of a problem because this rule is applied from proportions either way. Next, 25. And we went through proportions, so don't tell me I didn't teach it to you. 25. The histogram summarizes data set A, which represents the number of points per player earned by 50 players of a game. Yeah, whatever. The new player earns 18 points. Number of points. Frequency, 18 points. Okay. 18 points is like, number of points is like right here, right? Playing game, and this number of points is added to dataset A to create dataset B with 51 values. Cool. Which of the following must be true? So basically, you have one new player with that literally got just 18 points. Cool. Fine. All right. So basically, you have 26 players who scored between 50 and 60. 7 players scored between 40 and 50, and that's essentially how you're going to read this, right? So which of the following must be true? One, the median. So what's going to happen if you create like a statistical outlier? Well, if you create a statistical outlier, I mean, what we can do is we can find the median for each and every single value. Is that really going to change the median? The median is just a middle number. So out of 50 values, I have to count up to the 25th number. So right now I have 6. This is probably going to be like 7. So that's 13 right there. And then you have 26 here. Like clearly your median is here, right? Your median is going to be between 50 and 60. So is adding one outlier all the way to the left of the curve going to change anything? No. Your median is going to stay exactly the same. Okay. So median number of points per player, data set B. So median here is going to be identical. Median data set B is less than the median. No, it's not possible, right? Because median has to stay the same. It's going to be between 50 and 60. I don't see how it can possibly change. Oh, excuse me. And then let's go to number 2, the mean number of points per player for data set B. Mean. I really have to. Well, I can just think about it. I'm going to think about this logically, right? So the mean number of points per player for dataset B is less than the mean number of points per player for dataset A. Well, if you're going to add a statistical outlier, technically speaking, the average should hypothetically, okay, change. The average should go down, right? If you really think about it, because I'm adding in like a really small value here, okay? That's the way I would think about this. I mean, you could also just plug in numbers here and see what happens. So, but I'm pretty sure the answer is like 2 only. But because I'm super paranoid, okay, the way I would do this is I would have one value of 18, and then I would set a specific value. I just set like a middle number. So I'll go like 35 6 times, 45 7 times, 55 26 times, and then 65 what is that, 12 times, 65 12 times. Okay, and then I could find each and every single one. Okay, you can always do it this way. I'm not going to do that here because that's just going to take way too much time. All right, and I'm going to burn through this entire life just burning through this. Okay, but if I had extra time left over, I'd mark it for review, go back to this, and really make sure that my answer is right. But I'm pretty sure my answer is 2 only. I highly doubt. Well, I'm never wrong, so it doesn't really matter. So yeah, anyway, so that's the general idea as far as how I would do this. Next, how many distinct real solutions? Okay, immediately when you think like real solutions or like the number of solutions, you think should be thinking discriminants. That's my opinion. But discriminants only applies to something with x squared. This is not x squared. This is like x to the fourth. So the way I would do this is I would just set each and every single factor equal to 0. So I go x to the third plus 64 equals 0. So subtract 64, subtract 64. I get x cubed equals negative 64, cubic root of negative 64. And yeah, I know a lot of you are thinking just shove this into decimals and see how many times it hits. I'll do that in a second. Just hold off, okay? And what's the cubic root of negative 64? 4, 16, 64. So it's negative 4. Okay, it's not positive negative 64. It's just negative 64. So there's only one here because they're identical. And then if I go x to the fourth minus 81 equals 0, x to the fourth equals 81. The fourth root of 81 is 3, but it could be negative 3. So it's plus or minus 3. What's up again? Sorry, guys. My dog. Okay. X is plus or minus 3. So I have two answers there, one answer there. I should be exactly 3. However, I'm going to double check this. I'm going to shove this into decimals just like I always do because I want to make sure that I'm super prepared. Let's go into okay, whatever. Desmos SAT. So I'm gonna go and oh boy, I forgot what the actual values were. So x to the third plus 64. 54 parentheses x to the third plus 64 parentheses, oops, close parentheses, and then open parentheses x to the fourth minus 81. Close the parentheses equals 0. Okay, so 1, 2, 3, nice and simple. I don't have to go any further than that, but I actually solved that each one either way. So that's the idea as far as that's concerned. Okay, let's continue here. 23. The figure shown WZ, WZ, WZ. Oh, why is a random 18 here? WZ and XY intersect. Okay, who cares? We know that. And every single time you have a point of intersection, by the way, you have this angle equal to this angle because they're opposites, right? So then from here, I have YQ equals 21. That's this. And WQ equals 70. Where's WQ? 70. Cool. And XQ equals 120. Okay. What is the length of YZ? So we have no idea what this is. So the key thing here is to make sure you're paying attention to the make sure you're paying attention to well, I'm getting a lot of very, very strange things going on. And I'm on do not disturb, which is beyond ridiculous. The idea here is you have to pay attention to the angle measures. Okay, in other words, if I have angle A, let's just say, for example, If I have angle A, this is the opposite to angle A. This is the opposite to angle A. Do you guys see that? So the key thing here is to like understand that similar angles have to be exactly the same in that those kind of respects, right? So 120 is proportional to, let's call this Y, right? That's basically what you're looking for. And then I can clearly see that this angle is opening up to X and this angle is opening up to like an unknown thing. So if I think about that, I'm going to do purple with purple because they're proportional to each other. And then I could do blue with blue because they're proportional to each other, which means the only thing I have left that could possibly be proportional to each other is the 70 to the 21. So I'll do that like a light blue. Okay. That's essentially it. So that's what we're looking for. So I'm going to do, I always like to do small over big equals small over big. So clearly, like this is my small triangle because it's 21, right? And big one is 70. Big. Okay, cool. And the way I'll do this is going to be very colorful, but you guys will get the idea. I'll do green. Small over big equals small over big. I need YZ, so I'll do, oh, I don't even know what X, the problem here is that I don't know what the value of YZ is, and I only know the value of XQ. So that kind of sucks because I need to figure out what the other side could potentially be. Yeah, I don't know what it is because I need YZ. It's a little bit annoying, and I don't know what this actual value is. I guess it's going to require a little more work. So I can't do it like straightforward the way I would want to. But what I'll do here is I'm going to set these two proportional to each other because I'm going to try to find that actual value first. So I'll go small over big equals small over big, so y over 120. So if I do that, I get 21 times 120 because I'm going to cross multiply equals 2520. 70y, and then I'll divide by 70. So I get y equals 36. So I know this value here is 36. So now, can we see the proportion or the ratio to each other? I mean, if we really think about it, what is 120 divided by 36? Right? Because they have to be similar. So it's times 3.333, right? So what is the length of YZ? Am I missing something? I have to be missing something. I think I wrote something wrong. YQ is 21. WQ is 70. Because I am missing something. That was silly. Guys, sorry, I missed this one. WX is 60. I could have done it right away. Created massive problems. Regardless of the situation, I can do 60 divided by 3.333 now, or I can go back and instead of doing this whole chaos in green, I can do 21 over 70, right? Small over big equals small over big, which is the x over 60. Cross multiply here, 21 times 60 divided by 70, 18. Nice and simple as far as that's concerned, right? Let's keep going. 22. The function f is defined by the given equation. Which of the following equivalent forms of the equation displays the maximum value of the function as a constant or coefficient? Okay, you just have to be very careful with this because I have a strong feeling that if I graph this on Desmos, 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 they're all going to give you the exact same line. Okay, well, not line, but parabola. Okay, so Desmos is not going to help you in that way. Desmos is going to help you in a different way. Okay, and I will show you exactly how it will help you. First, I have to actually move my iPad around. Oh no, I just lost my iPad. Action. Fun. Give me a second. Try to get that back. Oh, went back. Cool. Okay, so if I pull this open, negative 6x squared, pull this on Desmos. So I'll go y equals negative 6x squared plus 60x plus minus 126. Okay, I get two values, 3 and 7. Okay, nice and simple as far as that's concerned. Now, if the values are 3 and 7, then what do I have to do here? I have to find the maximum value. So the 3 and 7, those are my actual solutions. I actually don't care about that. I'm looking for the maximum value. In this case, my maximum value is 524. In other words, my equation has to have the numbers 5 and 24 because that's the only thing that's going to be giving me a constant or coefficient. So you got to be very careful with there. So then clearly my answer is C. Okay. In case you guys do not know, this is in vertex form. This is standard form. This is vertex form. They love vertex form. If you ever get confused with something or you're running out of time, always pick the one with vertex form. It's going to be a parentheses x minus h squared plus k, where hk is the vertex. Okay. And when they're asking for min or max values, I mean, it's pretty clear. You don't have to do anything. You don't even have to shove it into decimals, but I did just in case. Okay. Next one, 21. The number A, I'm going to write this whole equation out. A is 55% less than the number B. When I do 55% less than, I'm thinking the percent increase decrease. So initial times 1 plus or minus the percent equals your final value. You all should know this value, this equation. So if I go 55% less than, which means I'm doing 1 minus 55% or 0.55, which becomes 0.45. Okay, so be very careful here. So A is 0.45, B. Number B is 320% greater. If I think about that, that's 3.2, decimal place 2 spaces over, 3.2 plus 1, which is 4.2 times 160. Careful with that. What is the value of B? I can plug this all into decimals right now. I don't have to, because I could just do 4.2 times 160. 672, and then times 0.45. So it's 302.4. Okay. Should be relatively straightforward as far as that's concerned. Next, 20. If I take this entire equation and go change this, make that to p to the power of 2 over 3 equals to t to the power of 9 over 7. Okay? That's immediately what I'm doing. Like every single time I see these exponent problems, I immediately do this because, sorry, I gotta pull this down because it's too annoying to write. I gotta keep switching for the keyboard to actually work because otherwise I'm not gonna type in each and every single one. So p to the power of 2 over 3 equals t to 9 over 7. Cool. Now I also get another equation, right? I don't really care about this. I don't care about this. Those are just constraints. That's just telling me that, okay, well, this thing actually will work. Regardless, where n is a constant, what is the value of n? Okay, let's really break this down. So if I do this out, I have to get the p or the t by itself. In this case, I would try to get the t by itself because look, I have one of the equations to be t by itself, and I'll show you why that's so important. So in order to get the t by itself, in order to get rid of this weird exponent thing, I'm going to do it to the power of 7 over 9. Okay, I always do to the power of the reciprocal because it's the only way you'll get rid of them. Because with exponents, you multiply the reciprocal. So it becomes 9 cancels, 7 cancels. That's the whole point of it. So you're going to go t equals p to the 2/3 times 7 over 9. So like the exponents will multiply here because it's C parentheses. So that becomes p to the power of 14 over 27. Cool. And now look, I'm going to rewrite that right underneath. I'm going to go t equals p to the power of 3n minus 1. Guys, you'll notice that the exponents have to be the same because the equations are the same, right? You guys see that? They have to be the same. So basically, I can say 3n minus 1 equals 14 over 27. Now we shove this in decimals, or I could solve this by hand. Plus 1, I get 3n equals 14 over 27 plus 27 over 27, which is equal to 41. 41 over 27 divided by 3. I'm going to write that here. 3n equals 41 over 27 divided 3 times 1/3. Divided by 3 is the same thing as times 1/3. So that becomes 41 over 81. Okay, nice and simple there. This one's like a big one. I gotta move myself so you guys see what's going on. Not that. But yeah, there we go. I'll move myself to the right. Cool. I still have to zoom out. Dear Lord, 19 is huge. Okay, regardless of the situation. A certain open star cluster, okay, got it, contains M-type stars and K-type stars. I'm getting a lot of phone calls today. A certain open star cluster contains M-type stars and K-type stars. The estimated total mass of M-type and K-type stars in this open cluster is 127,882 quadragrams. Who cares? Okay, I don't know where this is going, but anyway, the graph shown models the possible assumption of the number of M-type stars X and K-type stars Y that could be in this open star cluster if all the M-type stars have the same estimated mass and all the K-type stars have the same estimated mass. Okay, and okay, have the same estimated mass. Based on the graph, which of the following is closest to the estimated mass in quadragrams of each M-type star in this cluster? Each M types. I don't know what the hell this is saying. This is so complicated for no reason. Total mass of M type and K type stars in the solar cluster is 120. So the total amount. Oh, I see what's happening here. Okay, so if I had these are a number of K type stars, this is a number of M type stars. So in other words, if I pick any point on this graph, right? So let's just say right here, this is 110 and 40 ish. So together, it's not actually 110 and 40. It's actually supposed to be 120, like, and this is in the thousands, I guess. K-type stars, Y could be the value of star cluster if all the M-type stars have the same estimated mass and all the K-type stars have the same estimated mass. Great. Based on graph which the following is the closest to the estimated mass in quadragrams of each M-type star in the cluster. Okay. So basically, together, I know it seems like it's 110 and 40 because that's what it looks like, but honestly, it's going to be different value altogether because it's going to be 127,882. The key thing here that we're looking for is we're looking for the M-type star clusters. So I'm going to say I can probably even find an equation for this. I could probably even plug in points and shove them into decimals and see where I get. But I don't think this figure is completely drawn to scale because this value is really, really hard to see. I mean, let's try it. Let's do 155. Okay, 155, and you have 155 M type stars, but you don't have any K type stars, right? So I'm gonna have 155x has to equal 127,882. That should give me the closest answer, 127,882, which is 127,882 divided by 155. So it's 825. So it looks like the answer is probably A. Okay, not 1,000% sure. Not 1,000% sure, but I'm pretty sure that it can't be 938. I want to try this one more way just to double check this. So I'm gonna shove this into decimals. I'm gonna shove like specific points into here. I only have 1 point right now, but it can't be 110 and 40. It has to be a little bit less than that. Yeah, I guess there's no other way to really do this. I'm gonna try this one as well, which is 30 and 110. Again, I'm getting like random values because now I'm at like 140. Here I'm at 150 if I add them together. I don't like any of these. This is so strange. Okay, well, whatever. Regardless of the situation. Yeah, like, unfortunately, you're going to have to guesstimate. I don't actually mean guess. I mean, like, you can just specifically pick this point right here. And you're going to say, okay, this is about 155, 150-ish. Okay, it can't be 160. And if I do 127,882, 127,882, let's say I just say I did it divided by 160. And if I did divide by 160, I get 800. So, and if I make it 140, let's make it 140. 127,882 divided by 140, I get 913. So there's no way it's going to possibly be 938. So the answer has to be A. Okay. Again, double, triple checking. Okay, next one. 18. This kind of looks like a joke. Or am I crazy? This is way too easy. So the key thing here is you're just shoving this into decimals. There's nothing really to do here. And if I do that, plug in 24, -8. Oh, this is, oh, that's weird. Corresponding which equation defines F? Look, I would still do it in decimals. Okay, you plug in X is 24. Create table. What was it? X. So 24, -8, 30, -8, 24, -8, 30, -8, and what was it? 32, 8. Jumping around like crazy. 32, 8. And I want to create the actual graph here at home. I don't know if this is a line. Is then a line is definitely not possible. I guess I'm just looking for specific points that'll fit this graph. The quadratic, I guess, will work. Does it say it's quadratic? Oh, quadratic. Okay, so that makes things easy. So then I'm looking for the specific values, which one works for this. So if I do y equals x minus 24, x minus 30 plus 4, x minus 24, x plus 30 equals x minus 24, x minus 30, and then minus 24 minus 30 plus 4 plus 4. Yeah, that's definitely not it. Okay, I gotta do each and every single one, which is a pain. So that's minus 8. Let's see. That's it. Okay, so here, like green, blue, it's identical. Okay, so then the answer is clearly B. I would check it to double make sure, but whatever. For the sake of time, I'm just gonna go ahead and skip ahead. 17. Okay, this is the same exact problem. Back to Desmos. Okay. 17 for the linear function g, the table shows four values of x and their corresponding values of g of x. The function can be written as y equals mx plus b, where, okay, come on, this is like 132, 2, 4, 28. 132 plus table, 132, 2. Guys, and for those of you who are just tuning in, please follow. You can follow our Infinite Academics YouTube channel. You can follow our TikTok, Instagram. We give a ton of free information if anybody ever wants it. I did a whole YouTube tutorial. I go live every single Monday at 7 p.m. So please, by all means, join. Okay, we will be more than happy to answer any and all of your possible questions. 228. And what was the last one? I don't need that many because it's just a line. I only need 2 points for a line, so I'll keep it very simple. It's asking for B. What is the y-intercept? So I'll click this. A linear regression. M is -4. B is 36. So I'm done. Boom. I'm not gonna turn on the iPad because this is Desmos. The graph of y equals f of x in the xy plane passes through the points -5, 0, 1, 0, 4, 0. Okay, which the following must be a factor. Well, I don't have to do this Desmos for this one because it's a factor. So you need to understand these are roots, right? Anything with the y value being 0 is immediately a root, right? So if we think about any kind of like quadratic or even cubic, right? So this is going to be something 0, something 0, something 0, right? So this will be like, if it's -3, let's just say it'll be -3, 0. So the factor would be x plus 3. This would be 0, 0. Factor would just be x. This would be, let's call this 2. X minus 2, right? Or the factor is just, the root here is just 2. So it's going to be 2 comma 0. So it's always the inverse of the sign. That's the key. So in this case, one of the factors is x plus 5. Another one's going to be x minus 1. And then the last one's going to be x minus 4. So what's my answer? C. Cool. Oh, and by the way, whenever you see these types of problems, if you ever see a bounce, like this would be it's squared. So let's call this like, I don't know, -2. This would be x plus 2 squared. Just a heads up. Because it hits, you have two solutions, but only one of them is distinct. Distinct means different. Okay, so you got to be careful with that one. 15. The graph shows the estimated boiling point Y in degrees Celsius is a normal paraffin with a molecular weight of x grams per mole. Normal paraffin with a molecular weight of x grams per mole. Okay, where x is between 1 and 280. Okay. Fine. Which statement is best interpretation of the point 149.02, 186.05? Okay, so we had the boiling point here is y degree. So these are boiling points. Boiling points. And this is x grams per mole, so grams per mole. So if I look at the 149.02, the x value here is the grams per mole concentration, and the 186 is the boiling point. Okay, so If the concentration is 149.02 grams per mole, the estimated boiling point is 186. So molecular weight is 186. Absolutely not. Molecular weight, the normal power from the molecular weight of 149.02 grams per mole has an estimated boiling point of 186.05. The answer is B. I'll check the rest. Minimum estimated boiling point. No. The maximum estimated boiling. No, I don't know anything about the min or max. Okay, so there's no way that could be the answer. That's out. Next, 14. What is a radius of a circle? Guys, like I can shove this into decimals and solve it out, or you should know the equation x minus h squared plus y minus k squared equals r squared. R is clearly 13 in this situation. If you, what is it, x plus 2 squared, y plus 5 squared? X, if I plug this in, plus y plus 5 squared equals 169. Click those 2 points. So, and then I just want to find the distance. So just as a reminder, I would go distance, parentheses, and find my 2 points. Negative 2, 8. Negative 2, comma 8. Close. And then what's the other point? Negative 2, negative 18. Okay, and then I get my distance, my diameter is 26, which means my radius is 13. And I can find the center point by just looking for the midpoint, just in case. Okay. Next, two sides the same, right angle. Immediately, this is 45, 45, 90. X, X, X radical 2. Nice and simple. The answer here is just 45, because it has to be a 45, 45, 90, guys. It's given in the reference table. Line K is defined by y equals 6x plus 4. Line J is parallel. Parallel means same slope. No solution, same slope, whatever, okay? Passes to point 0, 5. Which equation? So you need a slope of 6. Oh, well, that was easy. Next, there are 240 players in the tennis competition. That includes 4 rounds of matches. Each player in the competition will play a match against another player in round 1. At the end of